Plan for this recording is to talk through application type problems for systems of equations. So that's kind of the plan. We'll do a few specific kind of problems that you'll see, and then we'll do a few miscellaneous problems. I know word problems, application problems are not our favorite, but hopefully by the time we get done, you'll have some better idea of where to start. It's kind of a thought process of how to approach some of these. First thing, as we read this problem, we need to figure out, am I looking for one equation or two equations? First sentence gives me a big hint. The sum of two numbers is 15. If I have a situation where there are two variables, I must have two equations. So I know I'm looking for two equations. Let's go ahead and start that first sentence. The sum of two numbers is 15. What two numbers? I don't know. So if I don't know the two numbers, I'll just call them X and Y. They're variables. If I use a variable, I must define it. When it says define your variables, it means what does X stand for? And X simply means a number. It simply stands for a number. Right where you can read it. So what is Y? It's another number. Nothing fancy. Okay? So X is one number, Y is another number. And I know the sum, addition, of the two numbers is 15. Is means equals. Okay? One number. So here's one equation. I need another equation. Second sentence. One number. Which number? I don't know. Does it matter? No, it just says one of the numbers is 4 times the other number. Sometimes it will matter which one. In this case, it does not. One of the numbers. You could have said Y equals 4 times X. Okay? So one number is 4 times the other. We have our two equations. So now we can solve. So I'm going to use substitution. Let's substitute what X equals in for X. So X equals 4Y. So I will substitute what X equals in for X. And now solve. 4Y plus Y is 5Y. Divide, and Y is 3. If Y is 3, and I know that X equals 4 times Y, then X must be 12. And there's my two numbers. One number is 12, the other number is 3. And 12 plus 3 does equal 15. As you're reading the equation, or as you're reading the question, ask yourself, is it one equation or is it two? Meaning, is there one variable or is there two? Then as you read, you're looking to try to formulate two different equations. All right, your turn. Two positive numbers have a difference of 5. Two positive numbers. I'll call them X and Y. They have a difference, so subtraction, of 5. So X minus Y is 5. The larger number, I can't just say one number and another number. One of them is larger than the other, and I need to know which one's larger. Because the second sentence, I need to say the larger number is. So is that X or is that Y? If you have a difference of a positive 5 and both X and Y are positive, the only way that can happen is if X is larger than Y. If I were to switch the order of these, my difference is a negative 5. And that's not what we have. We have a positive 5. So now in this case, I can't just simply say X is a number. I have to say X is the larger number. And Y then represents the smaller number. Okay? So back to second sentence. The larger number, x, is 1 more than twice the smaller. Notice the order in which I wrote that down. I didn't say x is 1 more than twice the larger number, the smaller number. Although that is technically correct. If I were to do difference, if it said x is 1 less than the smaller number, and you did that instead of x is 1 less than, that is very different. This and this are different. So when it says 1 more than or 1 less than, start off by putting it out here. It is 1 more than, so we're going to add 1 to something. What is it 1 more than? Twice the smaller number. If you do it that way, you will not make a mistake. Okay? All right. I'm going to use substitution again. Why? Because it says x equals. Nice setup for substitution. So I will take what x equals, 2y plus 1, and substitute it in for x in the first equation. Do a little bit of simplifying. 2y minus y is 1y. And so y must equal 4. If y is 4 and x equals 2 times y plus 1, then x must be 9. The larger number, x, is 9. The smaller number, y, is 4. And the difference between 4 and y, or 4 and 9, is 5. There are 2 examples of number problems. Coin problems. First thing, Ron has 12 coins, okay? Total value is $2.30. The coins he has are nickels and quarters. How many of each coin does he have? The question will most of the time, I'd say always, but I don't like the word always, most, if not always, give you your variables. How many of each coin does he have? I don't know. I'm going to use N for number of nickels because that's what I'm looking for. How many of each coin does he have? And I'm going to use Q to represent the number of quarters. Okay? N. I like to use the first letter of the keyword in defining my variables. N for nickel, Q for quarter, makes sense. A lot of people like to stick with X and Y always. You're welcome to do that. You can do A and B, X and Z, whatever you want. I will, if possible, use the first letter of the variable's keyword. So, first sentence, Ron has 14 coins. What kind of coins? Well, he has nickels and quarters. And so the number of nickels plus the number of quarters has to be the number of coins. He has a value of $2.30. I'm going to make this easier. I'm going to change that to 230 cents. So now when I go to the second sentence, the coins he has are nickels and quarters, and I know that the value of every nickel is 5 cents, and the number of nickels is N. So the amount of money he has in nickels is 5 times N. And the amount of money he has in quarters is 25 times Q. Grand total of 230 cents. Okay. The number of coins is one equation. The value of coins is the second equation. That is very common setup. One talks about the number of, the other talks about the value of. Okay, pick a technique. This one does not say N equals or Q equals, but I could make the first equation say N equals or Q equals pretty easy. So like N equals 14 minus Q, and I could use substitution now, but I'm going to use elimination this time. So I'm going to multiply the top by -5. Negative 5 times n is a negative 5n. Negative 5 times q is a negative 5q. And negative 5 times 14 is a negative 70. Add the second and third equations together. Add these two together. 5n, negative 5n go away. 25 minus 5 is 20. 230 minus 70 is 160. Divide, and q equals 8. There are 8 quarters, and if they have to add up to, whoops, 14, then there must be 6 nickels, because 14 minus 8 is 6. And we're done. Number of nickels is 8. The number of quarters, backwards, number of quarters is 8. Number of nickels is 6. Your turn. Hit pause. Come back when you're done. Tom has 21 coins. What kind of coins does he have? I'm kind of skipping through because we kind of know the process now. We have dimes and quarters. So D is the number of dimes. Q, number of quarters. And I know there's 21. So D plus Q is 21. Using the same trick, changing $3.45 to 345, I have 10D plus 25Q equals 345. If you don't want to do that, you could say 0.1D plus 0.25Q equals 3.45. Totally fine. Okay. Next step. Again, I'm going to use elimination. Multiply by negative 10. So I get my D's to cancel. I have a negative 10D minus 10Q is a negative 210. Add these two equations together. 10D minus 10D go away. 25D minus 10D is, 25Q minus 10Q is 15Q. 345 minus 210 is 135. And 135 divided by 15 is 9. Plug 9 back in. 21 minus 9 is 12. So the number of dimes is 12. 12 dimes and 9 quarters. So when you're doing a coin problem, you will have one equation that talks about the number of coins and one equation that talks about the number of values most of the time. Every once in a while there'll be a question that's a little different than that, but that is your basic setup. All right, mixture problems. Mixture problems is a type of problem that a lot of people do not like, but don't make them too confusing. I don't have one of these in the homework problem, but I think it's important for you to see them. So mixture problems. How much 50% antifreeze solution and 40% antifreeze solution should be combined to give 50 gallons of 46% antifreeze solution? First question, what does that mean? What does it mean to have 50% antifreeze solution? It kind of is what it sounds like. 50% of the solution is antifreeze. So if I have this container, and let's say it holds 10 gallons, that means that half of it, or 5 gallons, is antifreeze, and half of it, like 5 gallons, is water or whatever other mixture fluid is going to be mixed with this antifreeze. Okay? They won't be separated like that. They'll be blended together, but that's the idea. 50% of whatever amount you have in this solution is going to be antifreeze. All right, let's think back to the coin problem. In the coin problem, we had one equation that told me the number of coins. So let's use the same logic. We're going to have one equation that tells me the amount of solution. Don't care about antifreeze, don't care about mixtures and all that stuff, just how much solution do we have? So how much of this 50% antifreeze do we have? I don't know. X. How much of this 40% do we have? I don't know. Let's call that Y. So I know that I have 50 gallons. X of it is this 50% mixture. Y of it is the 40% solution, and I have a grand total of 50. So X stands for the number of gallons from this 50% mixture, and Y stands for the number of gallons of the 40% mixture. So a rough, crude picture is we have this canister, this tank or container of the 50% antifreeze. We'll go ahead and be fancy and draw it. We have this tank of 40% antifreeze, and we have a total of this amount. So we take whatever we have from here plus whatever we have from here, and it's going to equal 50 gallons. Okay, next question. How much antifreeze do we have? Now we're looking at just the antifreeze. Well, in a 50% solution, just like we talked about earlier, 50% of it's antifreeze. So to find 50% of something, we multiply the number of gallons of X times 50%. And that tells me the number of gallons of antifreeze from the 50% solution. We have 40% from the Y, and we have 46% when we're all done. So the amount of antifreeze is one equation, the amount of solution is the other equation, and now we're done. Not done, now we're ready to solve. I'm going to use elimination. You can tell I did some of these earlier. I had the answer showing up as I scroll down. So elimination, what technique do you want to use? Or not what technique, what tech, sorry, my brain's not working. Let me get rid of this first. So 0.46 times 50 is 23. So let's get rid of that first. Now, what technique do you want to use? Elimination looks the easiest for me. I'm going to multiply this by a negative 0.5. Okay. Add these two equations together. I get a negative 0.1 y and a negative 2. Divide, and y is 20. 20 gallons of the 40%. And if X plus Y has to be 50, then there must be 30 gallons of the 50%. And that should make sense, because if I were to add equal amounts of 50% and 40%, I would have 45%. So I must add more of the stronger solution, more of the 50% to get 46%. All right, there's mixture problem type. Miscellaneous problems. So those were your specific types of problems you could see, but then there's this category that kind of encompasses every other problem. So you could see almost any type of system of equation word problems. So we need to practice some miscellaneous type problems also. So give that one a try. Kidding. As I read this, my first question or your first question is probably, I don't know much about blackjack. Excuse me. But you really don't have to know anything about blackjack. This problem here is very similar to the number problem. Sorry, the coin problem. This is very similar to the coin problem. We're going to have an equation that tells me the number of chips, just like we had an equation that tells me the number of coins. And then we're going to have another equation that tells me the value of the chips, just like we had the value of coins. This is very, very similar. I could change this problem to say we have nickels and quarters and a total of $4.65. It would be the exact same setup. And 45 coins. Okay, so with that in mind, what do we have? We want to know how many of each chip do we have. So I need a variable to represent each one of those. X stands for the number of $5 chips. And Y stands for the number of $25 chips. I used X and Y instead of some other letter because there's really no other letter that helps me to define the number of $5 chips. So I just randomly used an X. Okay, we have 45 of these chips. So I know X plus Y equals 45. Okay, value. Each X is $5. Each Y is $25. So the amount of money we have in $5 chips is 5 times X, and the amount of money you have in $25 chips is 25 times Y. And the total amount of money we have is 465. Pick a technique. I'll use elimination. Multiply this by -5. Gives me a -5x minus 5y. What is that? 225. 5x, -5x go away. 25 minus 5 is 20. What do you get? 240. Divide. Y is 12. If y is 12, then x must be 33. 45 minus 12. There are 33 $5 chips. There are 12 $25 chips. Very similar to the coin problem. As you're doing these, how did I know there's two equations? There's two variables. How did I know where to find my equations? Look for totals. What do I have? I have 45 chips. Where do those 45 chips come from? Next question. I have a total value of $465. Where is that money coming from? And you'll have it. Look for totals. Look for what you can add together, subtract, etc. to get a grand total. All right, try this other one. Farmer has 96 feet of fence, which to make a corral. Corral is just a fenced-in area. If he arranges it into a rectangle, that's the key word, rectangle, that is twice as long as it is wide. What are the dimensions? If there are the dimensions, if it's a rectangle, dimensions, we have a length and we have a width. We have two variables. I need two equations. How do I know that the perimeter is what I'm looking for? Well, if I have 96 feet of fencing, I'm not going to put that on the ground in the middle of the corral. I'm going to use that to make the perimeter of my fence or of my corral. So the perimeter has two lengths, it has two widths, and I know that the grand total of fencing I have is 96 feet. So when I build this fence, the two lengths plus the two widths cannot be more than 96. It needs to equal 96 feet. Okay, the rectangle part was important because it told me what shape my fencing needed to be distributed into. Okay, twice as long as it is wide. That's a tough one. Seems like it's really easy. It's a tough one. Twice as long as it is wide. Which one's bigger, the length or the width? Is it going to be the width is 2L, twice as long, so 2L? Or is it going to be L equals 2W? Back to my question, which one's longer? If it's twice as long as it is wide, the length is bigger than the width. If my width was 5 in this case, if my length was 5 in this case, my width would be 10. And that says the width is bigger than the length. If my width was 5 in this case, my length would be 10. That is true. My length is twice the width. If it's twice as long as it is wide, the length is 2 times the width. Be careful on those. Those are some tricky wordings. All right, going to solve by substitution. Plug in my 2W. So 2 times L, which is 2W, plus 2W, has to equal 96. Using substitution. 4W plus 2W equals 96, multiplying those together. Adding those together, 6W is equal to 96. And take 96 divided by 36, divided by 6, and we get 16. If my mental math is correct, probably should check that. 96 divided by 6, 6 is 16. Okay, go back to my statement up here where the length is 2 times the width, which we just said was 16. Wow, hand's not working all of a sudden. And we have our two variables. The length is 32 feet and the width is 16. All right, there's some examples of application problems for systems of equations.